Alright guys, so now we are going to work on a lecture 4.1, graph of sine and cosine. Learning the shape of these graphs allows for quick sketching of linearly transformed graphs. And you should be able to sketch sine and cosine and everything around that, including the period, the location of extrema, the zeros, etc. I would like to remind you that you must remember the trigonometric circle value, trigonometric function value. Please, we have seen that already, how to find the first quadrant, and then you will be able to find all the other value in the other quadrant. So remember this, and let's try to work right away in the graph of sine. So the whole question, and you will see different things, what I don't like is trying to decide, oh, I'm going to take a value of pi over 6 and then pi over 3, and the question is, why are you taking pi over 6? Why are you taking pi over 2? So what I want to do is very simple. I just want to think about the sine and where on my trigonometric circle do I read the value of my sine. And what I'm going to do is very simple. I know that the sine is value of sine I'm reading on a vertical axis of my trigonometric circle. So what I'm going to write, it's very simple. What I'm going to write is sinus of my angle x, and I like to say angle x because most of the time you think x as a variable. X is a variable, but x is an angle in trigonometry. So sinus x equals 0. Well, I know that the sinus will be equal to 0 when the angle x will be equal to 0, or when the angle x will be equal to pi. So I know, for instance, that that is one point, and that is another point where my graph will have to go through. Now, what is the value of the sinus x equal 1? Because I know the sinus is in between 1 and negative 1. So I know that it's going to be when x equal pi over 2. When x equal pi over 2, I know it's going to be 1. So that is another value. And I'm going to also be able to say that when x will be equal to sinus x equal negative 1, when the angle is equal to 3 pi over 2. So at 3 pi over 2, I'm at negative 1. And when I'm at 2 pi, when x equal 2 pi, the value of the sinus x is also equal to 0. So what I'm going to do is very simple. I can graph my sine. And obviously, I can easily remember that when I have negative pi over 2, I'm at negative 1. Oops. All right, so let me erase that. Here we go. So I'm supposed to be negative pi over 2, I'm negative 1. When at pi, right, negative pi will be 0. Then negative 3 pi over 2, I will be at 1. And so forth. So this is how you graph your sinus, by just looking at the value of the sinus when it's equal to 0 and when it's equal to 1 or negative 1. If it was necessary to have x pi over 6, L 2 pi over 3, well, why not? But in that case, it's not. So what is the period? Well, the period is 2 pi. When you look at the period and you read the period horizontally, this is the value of the period, and the value of the period is equal to 2 pi. We can see that the graph is continuous over the entire domain. And below, you can see that my calculator is giving you exactly the same thing. The x-intercept occurs at n pi, where n is an integer, but I don't need to remember that. I can figure that by myself by just plotting sinus x equals 0. When? When x equals 0, when x equal pi, or when x equal 2 pi. Sinus x equal 1. When x equal 2 pi. Sinus x equal negative 1. Okay? All right, let's try to graph the cosinus by applying exactly the same idea on my trigonometric circle, I know that my cosinus is equal to 1. The cosinus of my angle x is equal to 1 when the angle is equal to 0 or when the angle is equal to 2 pi. So when x equals 0, I'm at 1. And when x equals 2 pi, I'm also at 1. Now, the cosinus of the angle x is equal to 0 when the angle is equal to pi over 2 or when the angle is equal to 3 pi over 2. Therefore, when x equals pi over 2, I'm supposed to be at 0. When x is equal to 3 pi over 2, I'm also supposed to be at 0. And cosinus x, cosinus of the angle, is equal to negative 1 when x equals pi. So when x equals pi, I'm at negative 1. So if I have to graph my cosinus, I can easily say that it will look like exactly, oops, I erased everything, so I'm going to do it again. There we go. It will look exactly like what my calculator is giving me. Obviously, when x equals negative 2 by effect of symmetry, I'm going to have a 0 right here. When x equals pi, I will be at negative 1. When x equals 3 pi over 2, 3 pi over 2, I'm at 0. And when x equals negative 2 pi, I will be at plus 1. And this is why I'm having, oops, I don't like that, so let me do it again. There we go. All right, maybe a little bit too pointy right here. It should not be as pointy than it is right here. So let me do that. Let me erase that part and let me do this part less pointy. There we go. All right. As you can see, the period is also equal to pi. As you can see, the period is also equal to pi. The graph is continuous over the entire domain, but I don't need to remember that the x-intercept occurs at 2n plus 1 pi divided by 2. My philosophy is if it's necessary to remember something, remember it. Otherwise, try to understand, and it will be easier to remember it when you try to understand something rather than to remember something without understanding it, at least for this expression 2n plus 1 divided by 2 multiplied by pi. It's quite difficult to remember that, and it's not necessary to remember it. All right. Now, graph of vertically stretched sine and cosine. You know what, guys? We are going to apply exactly the same idea. We have to graph y equal 2 sinus x. So the first of all, what I'm going to write is my sinus of my angle x is equal to 0. And I know it's equal to 0 when x equals 0, when x equals pi, and when x equals 2 pi. Therefore, 2 sinus x will be also equal to 0. So first of all, I know that when x equals 0, I'm here. When x equals pi, I'm also there. When x equals 2 pi, and by effect of symmetry, negative pi and negative 2 pi. Now, my sinus x is equal to 1 when x equals 0. When x equals pi over 2. When x equals pi over 2, that's it. But when sinus x equals 0, equal 1, that implies that y will be equal to 2. Why? Because we are having y equal 2 times multiplied by 1. Sinus x equal 1, 2 times 1 equal 2. Therefore, when x equal pi over 2, y equal 2. At pi over 2, I'm at right here. Now sinus, I can find when sinus x equal -1, that implies y will be equal to -2. And that does appear when x equal 3 pi over 2. Okay? Just to understand the y equal -2, because we got 2 multiplied by -1. So y equal -2 when you have the angle equal 3 pi over 2. So at 3 pi over 2, I'm at -2. By effect of symmetry, at -pi over 2, I'm at +1. I'm sorry, by -2, I am at -2. And then at -3 pi over 2, I'm at +2. All right? And so now if I graph my function, I got something like that. Just to remind you, if I wanted to graph on the same graph, so in blue right here, I got y equal 2 sinus x. If I wanted to write in red y equal sinus x, just to show you, what do we have? We will have something like that. And so I can totally see that I stretch vertically my function by multiplying by 2. All right, so now I'm going to ask you to do by yourself sinus y equal -1 over 2 sinus x. I just basically apply the same idea. The sinus x equals 0. That implies y equal -1 over 2 multiplied by 0, which mean y equals 0. But when sinus x equals 0, when x equals 0, when x equals pi, when x equals 2 pi, when the angle is equal to 0, pi or 2 pi. So when x equals 0, when x equals the angle equal pi, or when the angle equals 2 pi, and by effect of symmetry, it will be the same with -pi and -2 pi, I know that y will be equal to 0. When the angle equals pi over 2, I know it will be equal to -1 over 2. At pi over 2, I'm supposed to be here. So I know almost instantaneously that when x equals 3 pi over 2, I will be at +1. And this is what I knew right away. So I let you finish to graph this y equal -1 over 2 sinus x. And I let you finish by yourself y equal 3.5 cosinus x, and you will have to write every single step. All right, graph horizontally. So I'm going to ask you to graph sinus 2x, same idea, but remember, when we're pronouncing sinus 2x, 2x is the angle. When the sinus of my angle is equal to 0, it's when the angle is equal to 0 pi or 2 pi. Therefore, the angle being 2x, 2x equals 0, 2x equal pi, or 2x equal 2 pi. That gives me the value of x. Because remember, we are graphing y function of x, not function of 2x. Therefore, knowing 2x equals 0 give me x equals 0, x equal pi, and x equal 2 pi. X equal pi over 2 and x equal pi, telling me that y will be equal to 0. I'll let you read the sinus 2x equal 1 and -2, 1, and please graph your sinus 2x on this space right here. Same idea for y equal 1 over 2x. I'll let you read. It's supposed to be easy now after everything that I showed, because it's always the same process. The angle 1 over 2x equals 0. That means x equals 0. That means sinus 1 over 2x equals 0, which is y equals 0. So y equals 0 when x equals 0, when x equals 2 pi. And technically, I should have something right there when x equals 4 pi, when x equals -pi over 2, and x is -4 pi. When I look at 1 over 2x equal 1, y equal 1, when x equal pi. Please finish